There's the beep. Okay. Now, once again, as I was saying, exponents are, for some reason, extraordinarily difficult for teenagers to do, which of course is boggling to me because they are not difficult. They are the exact same thing over and over again. It is a pattern. It is kind of like saying you're walking down the street and you put down your left foot and all of a sudden you're like, oh my God, what do I do now? Well, you pick up your right foot and you put it in front of your left foot. Exponents are kind of like that. They're always the same. Doesn't matter what they look like. Doesn't matter if there's a variable. Doesn't matter if there's extra numbers. Doesn't matter if there's fractions. It's always the same thing. And yet, people have difficulty with it. Again, mostly because they're learning steps, not what they are actually doing. To do what you are actually doing, if you write it out, you cannot possibly do exponents wrong. Okay? I know, I read the schedule wrong. We're still on number 2, right? Yeah, I didn't think so, because I see exponents 2-1 up there, and I'm speaking about exponents. So the first question I ask you right now is, what is a power? And already, somebody is all ready to give me an example of what a power is. But that is, of course, not what the question is. That would be giving me an example of it. I'm asking you, what is a power? Define it for me. And of course, I mean in math terms. There's always some wise ass that says, like a social studies term, well, that's when you can make other people do what you want. Arshdeep, what's a power? Excellent. That is a very good mathematical definition. Well done. What does a power do? There's only 4 kinds of math. So what does a power do? Multiply. See, you now all of you, if you knew the answers to those 2 questions, didn't want to say it out loud, you can do this entire unit now, because that's all you need to know. Of course, you can't do this entire unit now, but that's okay. So what is a power? First, we're going to talk about what it is. It is a repeated multiplication. Because, of course, math guys are lazy. They do not want to write more than they need to write. Because back in the old days, there was no calculator. And writing was a pain in the butt. So they invented shorthand so they could not write as much. Especially back in the real old days when you had to dip your pen in ink, or even older, like the Flintstones, carve it out with a chisel. Okay, that was like what my folks had to do. Just kidding. So, you see here 2 multiplied 5 times repeatedly. Now, if this was 1522 and I was doing some mathematical work that required me to multiply 2 times itself 5 times, that would be a pain in the butt to write. So mathematicians invented this notation that we are about to show you right now. You all know what it is already. That's cool. But the point I'm trying to make is, since you already know what it is, and since that's all it is, this is not that complicated. So the first thing we're going to do is, over in our blank spot, is we're going to draw a power. But we're not going to draw a power with numbers, because drawing a power with numbers makes you think that it only works with numbers. That is not true. So we're going to draw in math class, when we draw something without numbers, what do we use? Letters. We use variables. So I've got a big X and a little y. Okay? The big X is called, as Arshdeep has already told us, that a power is made up of a base and exponent. The big X is a base. Now, that is very simple. And yet, that first concept is lost on many, many math students because they do not listen to the next part of the definition. They stop listening there. The big number is the base. And then they stop. even though I'm about to talk more. Don't stop listening. Okay? Everybody still listening? All right. And I even write it down, which also confuses me. The base is anything. Please, again, highlight, underline, Mrs. Bad Crumble, cloud around it, stars, exclamation points. I don't care. Something to remind you that it is anything. Oops, I started writing with my highlighter. What an idiot. Anything attached directly. Oh, now I just wrote a B instead of a D. Directly. I'm going to highlight that to an exponent. What do I mean by directly? What does the word in English directly mean? Is there a direct line that could be drawn from me to Craig right now? There's nothing in the way? Is there stuff between me and Craig right now? Yes, there's a document camera, a projector, jag, some desks. I can't do it. So you all understand what directly means, yes? Okay. So this x is a base. We all understand that because it's attached directly to an exponent, yes? Is that negative attached to an exponent? Holy. Directly to an exponent? No. So is that negative part of the base? No. That fact is what blows everybody's knowledge of exponents out the window. They cannot reconcile this statement to this drawing. Even though your eyes can show you that there is no direct path from that negative to that exponent, is there? There's something in the way. So can that negative be part of the base? No. That is the number one mistake you guys are going to make because you stop listening at the bigger number's the base. So you guys are all done with listening to that, right? You're aware that it is only the thing attached to the exponent. Cool? Yeah. All right. Next thing. This guy. That guy is the exponent. And I'm going to highlight him because that's another word you need to know. The exponent is the number of times to multiply it's the number of times to multiply the base. Okay? Please notice it is not ever in that definition what you multiply the base by. Okay? There is always a kid, even at the end of the exponents unit, that still tells me 2 to the power of 3 is 6. Because they say 2 times 3 is 6. Because they stopped listening here. Okay? All right. The whole thing is a power. Please notice I have highlighted in 3 different colors because they're 3 different words. You need to know what all 3 mean. Everybody cool? Now, of course, the very first column of our table tells you everything you need to know. There is 1, 2. So 2 has been multiplied by itself 1 time. There's only 1 2 there. So it is 2 to the 1, and we read it as 2 to the first. So what is this one? 2, because that's the thing that's multiplying. How many do you see? 2 of them. So that is 2 to the second. It gets a special name, though. it is also 2 squared. And we talked about that on Friday, square roots and squares, right? It gets a special name because it's 2 times 2, and it would make a square. Cool? All right. What's this guy? 2 to the 3. So that is 2 to the 3rd. And he also gets a special name. Does anybody know it? 2 cubed. And then there's no more special names. This guy is then 2 to the 4th. 2 to the 4th. And we stop there with the special names. I'm going to give you guys a real handy dandy piece of advice. Be comfortable with the 2 to the y values. Be good with 2 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be very helpful to you in math as you go further if you have an understanding of what 2 to the up to 10 is. It will help you a lot. And you will notice an interesting pattern with it too if you ever take the time to look at it. It's a very useful pattern. You will notice that it exists in a great many things that you are comfortable with. I'm not going to say anymore because I'd like to think that some of you will actually look at that pattern and see if you can figure it out. But that's another story for another day. More importantly, I have to write a big star thing here, which I am also going to highlight and put a Mrs. Bad Crumble cloud around it. All right? We never write the exponent of 1. Okay? But it is always there. Mrs. Bad Crumble cloud of blue. Mrs. Bad Crumble is my nickname for all elementary school teachers. Because my elementary school teachers were old British ladies. It was weird. Yeah, they were all British. Until grade 7 when I had an old British man. I don't know why. Even my grade 4 teacher, whose name was Mrs. Cherkasov, which sounds like it's not an English name, but she was an English woman who married a Russian. What do I mean by that? 3. What's the exponent? 1. X. What's the exponent? 1. 1/3. What's the exponent? 1. Why? Because we never ever write it. Just like we never write the 1 that's technically in the denominator under 3. And technically in the denominator under X. Everybody got that? There is always a 1 here, but we don't write it. Why? Because math guys are lazy. Okay? Buddha? Buddha. All right. So you guys should already be able to do this. Go. What's this as a power? 4 to the 6th. Because 4 repeats 6 times. Now, this is key. This is what we call exponential form. All right? It is not evaluated. We are going to talk about evaluating in a moment. Okay? That is exponential form, which means it's got a base and an exponent. Everybody cool? It is not the value of that expression. Because that is going to be a really big number, isn't it? Right? 4 times 4 is 16, times 4 is 64, times 4 is 256, times 4 is 1,024, times 4 is 4,096. Okay? What's this guy as an exponent in exponential form? 3 to the 1. Would we ever write that? No. Because the 1 is what we call implied. Everybody good? Great. Go. There's a couple of weird, tricky things in there that I have not discussed. I would like to see if you can use the information I gave you to figure out C and E. Because there is a very subtle difference between C and E and the exponent that I drew at the top. So this guy is 2 to what power? 6. I only want to do 1 right now. We'll talk about 2 in a second. How many 5s you see? 1, 2, 3, 4. So there is 5 to the 4th. Now, what is weird about C? It's got a negative sign. What else is weird about C? It's got brackets. What do brackets in math do? It means we're going to multiply, yes. And what are we repeatedly multiplying? Look again. Negative 10. So since we're repeatedly multiplying negative 10, what automatically is the base then? Negative 10. But Mr. Myers, you said that unless the negative has a direct line to the exponent, by the way, how many times are we multiplying it? 3. So what must I add to this to make it correct? Brackets. I must add brackets. Because without the brackets, is this negative going to repeat? No. The brackets hold it together. Does everybody understand that? Just like in the first unit, if I needed to multiply a negative rational number, I put brackets around it to hold the negative with it. Does everybody get that? Okay? Down in the blank space down here, we're going to put a couple more notes to speak to that. But I wanted to make sure everybody could figure it out on their own. What's this guy? 4 to the 2, which is 4 squared. And then this guy? Negative 7 in brackets to what power? 6. Everybody cool? All right, now here's what I want to show you. X squared, so any number squared means x times x. Cool? Right? Okay. Negative x squared. Is there brackets there? So what does that mean? What's the thing that's going to repeat? No, just the x. So this is x times x, but the whole thing will stay negative. Everybody understand? Then what's this? Now the negative repeats. Negative x times negative x. Does everybody see that very subtle difference? That causes no end of grief in math for teachers and students not understanding this. Even though you all say, oh yeah, I got it. Yeah, the brackets are like a fence. They hold it all together. When you say you've got it, really have it. Okay? Without the brackets, the negative doesn't come along. Okay? I don't care what you have to do to remember that. I don't care what mnemonic device you have to think of. But you need to understand that. Now, of course, filling in this chart should take about 2 seconds, right? What's the first one? Second one? Two ways to read it. I'm going to be lazy and write 7 squared. That's how lazy I am. Why? Because I'm a math guy, and math guys are lazy. Okay? Okay. 3 to the 6th, 2 cubed, and then I'm so lazy I'm going to draw a cube. But what is it really? 2 to the 3rd. Is everybody okay? Honestly? Okay. Not a word of a lie. That's everything you need for exponents. If you really understand this, then nothing else is difficult. But you have to really get this. Cool? Okay. Now, notice here I have changed the word. Evaluating powers. That means I want what the result of the repeated multiplication. I forgot the is. What is the result of the repeated multiplication? So what does that mean? No exponents. But that is only when we are evaluating. Okay? Evaluating in proper math speak is standard form. That's why they're both highlighted in yellow. Okay? Now again, this becomes difficult if you are at the beginning, if you refuse to show me your work. So in your notes, like always, we do every single step, don't we? Because this is the learning time. What does this really mean? 2 times 2 times 2 times 2. That is repeated multiplication, which is why it is highlighted in blue. I asked for 2 things in this question, didn't I? I asked for repeated multiplication and I asked for standard form. I have not put it into standard form yet, have I? You guys must put it into standard form. So let's do that. What is 2 times 2? 4 times 2? 4 times 2 is 6. 8. 8 times 2 is 16. This is standard form. Everybody good? Okay, what's this guy in repeated multiplication? 5 times 5 times 5. When you're showing your work, I don't really need them when you're doing positives, but when you're doing negatives, Paneet, if the negative is part of the base, then I need to see them. Okay? Because if this was a negative in brackets, it would be 5 minus 5 minus 5, which would look bad. And this answer is, of course, what? 5 times 5 is? Times 5? 125. There is standard form. Now, all of you are aware that math guys are lazy. I've said it a million times. They are still lazy even when they get a calculator, which is what allows them to be lazy. So all of you have seen this on your calculator. I know you have. I'm going to bring 2 different calculators up on the screen. On your calculator in front of you, you need to find this button. It's got either a Y with an X or an X with a Y, or for some people, because they've made calculators so, I don't want to use that word, they have made calculators so user-friendly that you don't actually need to know any math to do it. So you are looking for either x with a little y with a little x, or a blank with a little blank. That is the newest way I've seen a calculator written. One of those three buttons. Okay, y'all find it on your calculator? That's the exponent button. If you don't have one of those three, you have one of these little mountains, which is called, believe it or not, a caret. C-A-R-E-T. Not what's up, dog? Okay? Those are the buttons you need. So on a calculator, and you all already know this, or most of you do, I hope, and I like to do my calculator writing in green, to punch this into your calculator, it's base, whatever it is, your exponent button, and I'm so lazy I'm only going to use the caret, then your exponent, then often you need equals. So what would I punch in here? 2 exponent 4 equals. What would I punch in here? 5 exponent 3 equals. Everybody good? Yeah? Okay. I want for you to do this chart right now. Okay? You'll probably need your calculator. Again, there's a bunch of white space out here because that's where we're going to show you the exceptions, like how to do the weird stuff. This is the easy stuff. This is walking. Over here is the ballet. Got it? So go, fill in that chart. Son of a motherless goat, do I? No, I don't. Oh yeah, the next one doubled up, didn't it? Wild. Hope that didn't happen on here. Nope, didn't happen on the computer. Don't know how it printed to, but that's okay. Okay, so of course we're all done now, yeah? What's this guy? 6 times 6. 3 times 3 times 3 times 3, which is what?
81.
81. Everybody's got good calculator skills. 10 times 10 times 10 times 10. 10,000. 8 squared. 8 times 8. 64. 7 cubed. 7 times 7 times 7. 343. Cool in the gang? Everybody can do it, right? Okay.
Why is 7 cubed 137?
7 cubed.
Because it's cubed, so it's 7 times 7 times 7. Okay?
Alright.
Alright. Now remember, over here we're going to do the weird stuff, right? What would you punch in to your calculator? Actually, we're not going to do it with the calculator. We're going to use our heads first. What would negative 2 cubed be? Use your heads, write it out, and then tell me the answer. How would I write this out in repeated multiplication? Remember, we just wrote this down on the page before at the bottom in blue. What repeats? The base or the exponent? The base repeats. What's the base here? 2. So it's 2 times 2 times 2. That covers the base and the exponent, yes? We know that 2 times 2 times 2 equals what? 8. We just did that. But what about this guy hanging out here? He goes back on in both places at the end. Now, would a math guy write negative bracket 8? What would the math guy write? Just negative 8. Does everybody understand that one? Now remember, I'm going to talk about this with calculators in a minute, but the biggest mistake you guys make is you go to your calculator before you're ready, before you understand what is going on. Is everybody with me? All right, let's do the next one. Again, we're only using our brains. What is negative 2 cubed? Write that out properly. What would that be? Negative 2, negative 2, negative 2. And that gets me what? No. Negative 2 times negative 2 is positive 4. Times negative 2 is? What's positive 4 times negative 2? Negative 8. Is everybody cool? Notice the difference. Everyone is good? Okay. Now we're going to move on to the next thing, because as you can see, I have a whole section on using negatives. But before we go to it, I wanted to make sure everybody understood this subtle difference. Everybody is cool with it? Okay. So you guys already know how to do this. What is the base here? Why is it negative 5? Because there's brackets. And what do brackets in math do? No. It groups. They group things together. Okay? So the base here is negative 5. Everybody good with that? Okay. What's the exponent? 4. So what does that mean for us? It means negative 5 is going to go 4 times. Correct? Everybody with me? Now, you guys are smart kids. What's a negative times a negative? Positive. A positive times a negative is? And then a negative times a negative is? So you know this answer is going to be positive, don't you? But how do I punch that into my calculator? Before you go to your calculator, you look at that and you say to yourself, self, that has to be positive. Because it's negative, negative, get me a positive. Negative, get me a negative. Negative, get me a positive, right? So now everybody try to punch that into your calculator. I'm going to call up one of my calculators and I'm going to show you in a moment. Everybody try to punch that in. So I'm going to go negative 5, crap, negative 5, and then I need my exponent button to what power? 4. Everybody agree? Enter. Enter. What? How can it be a negative? I didn't put the brackets. And a great many of you are going to do that when I ask you to do this on your calculator. Okay? So when I punch this into my calculator, I gotta go bracket negative 5 bracket exponent button 4 then equals. And then what happens? Bracket negative 5 bracket exponent button 4 equals. Is everybody good? Now here's the thing. Sometimes, I've found this out in the last year or two, there are some less than effective calculators that actually will show a positive 525 without the brackets. A positive 625. That's really, really bad. Because that's bad math. Okay? Everybody understand? If the brackets are there, you've got to put it into the calculator. Okay? So now look at this guy. This guy's different, isn't he? What's this guy's base? Just 5. No negative, because the negative isn't in brackets. So what does that mean? And the exponent is what? 4. So what repeats? 5 4 times or negative 5 4 times? 5. So this is 5, 5, 5, 5. With a negative in front of the whole thing. So that is 625, which we know is the answer, but there's a negative in front of it. Is everybody good with that? So how would that punch into my calculator? Negative 5, exponent button 4, and you should get negative 625. Now, Riley, I'm assuming you're not using a real calculator. Exactly. So, you hopefully have not turned your brain off as soon as I said go to your calculator. You hopefully were still listening when I said before you touch your calculator, you have a look at the situation so you know if your answer's going to be positive or negative. Right? Cool? Everybody good? Okay. Now, over here I want to show you a couple of things. One of them you already know. X cubed is going to be positive, right? Because it's a positive times a positive times a positive. Cool? What about negative x cubed? Is that going to be positive or negative? Negative, because there's a negative out in front, which means whatever happens afterwards, it's going to be negative. Cool? Okay. What about negative x cubed? What's that going to be? No. Negative x cubed. Still stayed negative, yeah? So that guy's going to be negative. Now, what about negative x squared? You're just saying them both, Aiden. Which is it? Take a stand. No! Why? Dylan?
Is the negative still in front?
The negative is still out in front. So this guy is negative, which then blows people's minds because they want to say, negative times a negative is a positive, like you did on the first day. But that negative isn't coming with you, is it? So what is this? Negative's coming with you, so it becomes positive. Is everybody cool? Now expand that. I have a negative base to 3, and it's negative, right? So what would a negative base to 5 be? Positive or negative? You're just saying both. She says negative, he says positive. Which is it? It's negative. Why? Because it's an odd exponent. Negative times a negative times a negative times a negative times a negative. So what is negative x to the 6th? Positive. Everybody cool? Again, all these shortcut things are completely unnecessary, aren't they? They only save you time, because if you actually understand exponents, the very first thing we talked about, this makes perfect sense, doesn't it? Because if you understand the very first thing we talk about, you understand that that bracket brings the negative along. And if you remember the first unit, negative times a negative times a negative, that has to be negative. Everybody good? Great. Fill in the next chart. Go. Wait until you get to D. Nope. Because the bell is going to ring in 5 minutes, and you can hold your urine that long, because you're a real man. I'll tell you guys a little fun story about the psychology department at Stanford University in a moment. Would anybody like to tell me the base in number 1a yet? The base is -1. Why is it -1, a BA? Because it's in the brackets. Which means that -1 has to come along. Since the negative base with an odd exponent, what's the answer? -1. Because negative times a negative is positive times negative is a negative. Is everybody good? I'm going to take a moment to let this sink in. Is everybody okay? This is problematic. Okay? I have had friends who have taught math but not been math teachers that forget this and screw it up and teach it wrong. Does everybody understand what that bracket does? Okay. So that means this is no problem, right? What's the base in B? 10. Which means what is repeated? 10 times 10 times 10. But what's out in front of all of it? A negative. 10 times 10 times 10 is 1,000. So this is -1,000. Gouda? Great. What about C? -7. So what repeats? The negative repeats. 2 negatives when multiplied gets us +49, yeah? Now what's the shortcut? Oh, there's a negative base and it's an even exponent, so I know it's positive. Now let's look at this one. What's the base? -5. Now somebody is going to screw it up. What repeats? The -5 repeats 4 times, yes? But what else is there in this expression? There's a negative out in front of all of it. So this part is going to be positive, isn't it? Because it's a negative base with an even exponent, right? And we know that it's 625, don't we, from doing our earlier work. But what's out in front of it at the very end? -625. That wrecks kids. Okay? I don't know how else to make it not wreck you except to explain it. Is everybody cool? Dylan.
If we have that question with the odd exponent or an odd exponent, would it still be a negative or positive?
Okay, let's think about that. That's a great question. What would happen if it was -5 to the third? Well, then it's going to be a negative in the middle, yeah? With a negative out front. What's a negative times a negative? Positive. That actually is what was going, my next note in this blank space was going to be that exact thing, Dylan. You're brilliant! Okay, go pee. Not all of you, of course. That would be difficult. So, we've covered negative bases, or regular bases, negative bases, exponents, exponent of 1, okay? There's 2 other special kinds of exponents. In grade 9, we only cover one of them, and that is what we're going to talk about right here. You guys are smart kids. 5, 4, 3, 2, 1, what's the next number?
0.
3 to the 0. 3, 5, there's 5 of them, 4 of them, 3 of them, 2 of them, 1 of them. Is there any way to write this as repeated multiplication? No, because there's nothing repeating, yes? So there's no way to write that. And then look here. 243 divided by 3. Well, that makes sense, because when we were going upwards, we did one more multiply, right? So when we go downwards, we must do the opposite of multiply. Divide, 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 divide. So what then is 3 divided by 3? 1. If something happens once in math, how often does it happen? Every time. So if you have a base to the 0 power and it equals 1, then what does it mean if it is any base to the 0 power? It is 1. Always. Whatever the base is to the 0, it's 1. What if it's 10,375,229 to the 0? 1. What if it's 0.0000000000713 to the 0? 1. Everything is 1. It's not hard, is it? Okay, now let's see if you really understand everything we've talked about. What's this guy's value? 1. What's this guy's value? Every time. What did I just say? Every base to the 0 power is 1. Is that a base?
Yes.
So what is it? No. Every base to the 0 power is 1.
I said 1.
Okay, I know some of you said 1, but a great many more of you in louder voices said, no, no. Okay? Watch. X to the 0 is 1, because the base is x. Negative x to the 0 is what? 1, because the base is still to the 0. Cool? Negative x to the 0. Negative 1. The base is x. X to the 0 is positive 1, but there's a negative out in front. Got it? Cool? Okay. That door cannot close because it locks automatically. And it's a pain in my rump. Everybody good with that? This really messes kids up again. But you guys should be noticing by now that on the page right before here, I don't want to hear your music because, of course, I'm talking. And you, of course, would not have your earphones in while I'm speaking. Yes, I'm taking everything because you can't follow a simple rule. We had a very frank discussion on the first day. I'm taking your earbuds and I'm taking your phone because when I was talking here, I looked over and you were monkeying around on your phone. The sooner you learn these lessons, Panit, the easier your next 3 weeks are going to be. Just put it down and walk away.
Okay.
There you go.
Do I get 3 strikes?
No. You get 3 strikes when you don't piss me off. There is the thing that messes kids up. This right here. But you will notice that it applies perfectly to what we just did on the previous page. Right? You cannot forget something that was done 10 minutes ago because this looks different. So, you don't need a calculator for this. What's this? 1. What's this? 1. What's this?
1.
What's this? Negative 1. Right?
Right.
Everybody's good?
Yes, sir.
Okay. Powers of 10. Last thing for basic exponents. Write as a power of 10. Normally, I would take a long time to explain why this works. Summer school, we're out of time. Okay? As soon as you see powers of 10, all you got to remember is the number, that's not a hashtag, it's number. The number of zeros is the exponent. So, how many zeros do you see here? 4. So that's 10 to the 4th. How many zeros do you see here? 3. So that's 10 to the 3rd. How many zeros do you see there? 2. So it's 10 squared. How many there? 1. So it's 10 to the 1. Would I write 1? No. Why?
Because you don't write 1.
Because we never write 1 as an exponent. How many zeros do you see there? 0. So it's 10 to the 0. Do we write 0 as an exponent?
Yes.
Yes, every time. Got it? So, what's this guy? 5. What's this guy?
10.
What's this guy?
Negative 7.
And what's this guy?
10.
1.
1. Good? Okay, it is work time. Your outline has a crap load of work. You will not be doing all that work. You will be doing the following for the next 20, 25 minutes. On 55, you will be doing numbers 4, 5, 7 and 8, 9, 12, 13, and that's it. And on 61, you can actually do that because that's so short, it's no big deal. So this unit, we're doing the yellow highlighted stuff. If you need a textbook, they're over there. Everybody gets to work on it. It is work time, you can use it. Next time I see it, it's mine. Huh? Of course. Like I said, guys, this is work time. I don't care what you use it for. Right? But we do still need to make sure we know our exponents because you're going to be doing quizzes and tests on that very soon. Okay? Okay.
Wondering why you're carrying a picture in your pocket.
It's actually mine.
Oh,